Welcome to Maths with Bob. Today we are looking at results for complex numbers. We're going to be using the DeMoivres theorem and binomial theorems. Okay, basically these ones are going to allow us to do some expansions, and we're going to be able to create powers for sine and cosine, and also be able to create what's called multiple angles, the ntheta or 5 theta, sine 5 theta, those sorts of ideas. Okay, so how do we do it? Well, the first thing is we need to actually look at DeMoivres theorem, and we need to actually look at some special results when z plus z to the minus 1, we can see here is 2 cos theta. Let's see if we can actually okay, have a look. Okay, this one here. Okay, 2 cos, so that is z plus z to the minus 1, when now z is actually just cis theta, not r cis theta. Okay, alright. Okay, we also need z minus z to the minus 1. Okay, you can see here, this is over here. Okay, this is the 2i sine theta. So when we do that substitution, we're going to have a 2i in front of the sine theta. So we need to watch that. Okay, all right. So let's have a quick look at the next page. Okay, so here you can see here we've got for cos to the power n of theta, we've got to raise z plus z to the minus 1 to the power n. And you can see here I've just done an example, cos to the power 4 theta. Now you remember this is going to be 2 cos theta to the power 4, which when we expand out that binomial 4z plus z to the minus 1, we are going to get some results which we can group up into like z plus z to the 4 plus z to the minus 4, and 4 lots of z squared plus z to the minus 2 plus a 6 on the end, you can see here. So that you might remember, if you have a look here, okay, we've got we have a 2 to the 4 here, okay, at the front of cos to the power 4. So we're going to have to divide through by that, which you can see is 16, and eventually we'll get our cos to the power 4 of theta 1/8, big brackets, cos 4 theta plus 4, cos 2 theta plus 3. Okay, that wasn't too bad. Okay, let's actually look for one for sine. You can see here, if we want sine, I've done here sine to the power 5 of theta. Again, a similar sort of situation, but if you just have a quick look, we are going to have at the front here a 2i to the power 5, so we're going to have i's floating around, which we can divide through by eventually. We've got 32i at the front, and if you can follow through, we just use binomial, regroup z5 and z minus 5, and then 5 lots of z cubed minus z to the minus 3, and then 10 lots of z plus z to the minus 1. Now remember, z is actually just cis theta here, and eventually we'll end up getting 2i sine 5 theta minus 10i sine 3 theta plus 20i sine theta. Now, they've all got i's, so we can at least divide by I, and we divide by 32, and we end up getting that it's 1/16 of sine 5 theta minus 5 sine 3 theta plus 10 sine theta. Okay, what about multiple angles? Okay, so let's actually have a quick look. How are we going to get multiple angles? Now, you can see here, so if we need cos n theta instead of cos to the power n theta, we are now going to have to expand out cos theta plus I sine theta to the power n and take the real part of that, because you can see here that will be just cos n theta plus I sine n theta, and the real part will just be cos n theta. And if you look at the example here, I've done cos of 4 theta, which is just the real part of, you can see here, cis theta to the power 4. So I'm now going to use the binomial on cos theta plus I sine theta to the power 4. Okay, a fair bit of expansion here, but I've got to take the real part. Okay, so the first thing is to realize that, okay, this is going to be the important part here, that in fact we need to take the real part. Okay, we need to take the real part of cis theta to the power 4. Okay, so we're now going to take the real part, and you just see here, so we just pick out all the real parts. Okay, so what is cos 4 theta? Let's have a quick look. Cos 4 theta. Okay, you can see here, I'll try and expand this. Our little circle doesn't want to expand. Okay, alright, so you can just see it's cos to the power 4 theta minus 6 cos squared sine squared, and 4 sine to the power 4. Now, a lot of times you will be asked to just express in terms of cos or sine, so in this case I've just got to expand out all my sine squareds to get them into cos squareds. And eventually I'll get 8 cos to the 4 theta minus 8 cos squared theta plus 1. Okay. Okay, let's look at a result for sine now. Well, if we need to find the sine of n theta instead of the sine to the power of n theta, we've basically got to do a similar sort of result to the cosine of n theta. We now find the imaginary part instead of the real part of cis theta to the power n. And from DeMoivres theorem, we know that cis theta to the power n is cos theta plus I sine theta. So we now pick out, if you like, the imaginary terms from the expansion of cos theta plus I sine theta to the power n. And you can see here I've done an example for sine 5 theta, and you can see here that in fact it's the imaginary part of cis theta to the power 5, which is cos theta plus I sine theta to the power 5. We need to expand this out. Now we're going to I'm just going to try and see how this magic pen works. Here we go. Yes. Now, so sine theta. Now, what are we going to do? Well, if we actually have a quick look, we take the imaginary part of cis theta to the power 5. Okay, as you can see here, it's just, a big expansion. So we've now got to expand out this using the binomial theorem, and we eventually get down here, and we've got to basically pick out the real and imaginary parts. And again, we have to watch out for powers of I. I to the power 4 is 1, etc. And so we now need to pick out the imaginary parts in the expansion, and you can see here that sine 5 theta is 5 cos to the power 4 theta times sine theta minus 10 cos squared theta sine cubed theta minus sine to the power 5 of theta. And usually, if you want to try and express it just in terms of sines, or sines to the different powers, we need to replace all the cosine squareds by 1 minus sine squareds and expand out. Eventually we'll get what sine 5 theta is 16 sine to the power 5 theta minus 20 sine cubed theta plus 5 sine theta. Well, that's all there is for today, and thank you for watching, and bye for now.